Hello and welcome. We are going to be working on Chapter 3 of the DataMesh book, and Varsha is going to be leading our discussion. While Varsha's getting set up, if you're watching the recording, I'll just remind you that we have a Slack, we have weekly or every other week meetings, and then I have a YouTube channel with all the recordings if you want to join at any time or watch on your leisure. And then I have an associated GitHub repository with notes. And if you want a PR to that or get access, just let me know through the Slack.
So we'll be doing the chapter 3. That's the principle of data as a product. So what I figured out here is, now in this certain chapter, she's talking about more precisely on the concept, what she's trying to explain in prologue rather. Where we were just thinking about how would it look like when she says, when she was using the fancy words, and we were just thinking of how would it fit in. So here it's coming up better. So here when I see this, it's more of discovering, understanding, trusting, exploring, and ultimately consuming quality data. So I see this is the complete one line which says the data as product. So here, I mean, what I remember is the first 2 chapters, we were talking about how we are getting the data as a product. So this is how it has been explained here. And but it's pretty much same like we were doing earlier, as in when we talk about the the reliability of data. So all few terms have been explained well here: the feasibility, valuable, usability, these things. So here this small subset is now which she has shown as data as product. So this subset would hold all 3 major qualities, what it should hold.
So I think that this is really important and something worth emphasizing, because a lot of people I know who skim the book or kind of read the Cliff Notes or the Wikipedia article get really stuck on the data as a product concept. They think that it means that you need to be ready to monetize data, and it's really about how you approach data, and in particular data quality. Going back to my programmer days, it's a lot about the difference between a productized piece of software and something you have for internal use. For internal use, yeah, you fix the bugs when you get to it. You maybe don't have as robust a testing process. But for something that's productized, it needs to be right, perfect, high quality every time. And that's what I think that this is really emphasizing.
Yeah, so here when she says is feasibility, valuable, usable. So everything is coming into when we practically think of data, and it's typically the analytics, the filtering out the useful data. That's all. So here I see a line saying that high friction and cost of using data. So high friction means is where the analytics is involved, lots of filtering is involved, and you're just making it more useful and finding the right audience, whom you're going to serve this. I would rather say people who want to consume this. So this comes in this way. Friction will only be coming up where you're churning and you're just, we are trying to pull in a lot more, what should I say? Should I be saying the governance? Should I be saying the more useful way of presentation? Because everything is just into a lake where she's trying to put the mesh as a concept and now taking up from there. So it's more like a complete lake and pulling out the data which is more useful here. That's what I understood out of it. What do you say, Lynn?
Yeah, I mean, having tried to work with data lakes for many years now, because I'm mostly working in genomics, you know, they have a lot of promise, but the problem is buckets aren't good enough. That's really what it is. Buckets do not suffice as an analytical source. And so there's been third-party software, there's been custom solutions, but there hasn't been like a straightforward answer. And you know, we're hoping through data mesh principles, there starts to be more products and solutions. But I certainly know the problem, because the promise is, particularly in my domain, genomics, because they ran, you know, I've constantly talked about running out of space and not being able to afford the storage in traditional systems. But what the customers have done is just thrown everything in buckets and not been able to get value out of that. In fact, that has cost a lot of customers a lot of money, because they've not thought in terms of data as a product. They've thought in terms of it as a resource. And so copied it lots of times, unsynchronized copies, because access is poorly understood. That's just, you know, before you even talk about high quality, in my case, there's a lot of questions around access. You know, you have different researchers in different areas in different parts of the country, parts of the world. And so it's kind of more foundational in the genomic case, that lake scale was needed, but lakes weren't enough.
So when we talk about genomics, where do you see the friction is coming then?
Buckets aren't usable.
Okay.
That's really what it is. Buckets aren't good enough. There needs to be a layer of governance and services and management and compute on top of it that's more aligned.
Very true. Very true. So when they talk about the aligned customers here, do they mean the right audience to consume those data? Okay. So here, yeah. Are you saying something then?
No.
Oh, okay. So here, with this pictorial presentation, she's just trying to say that it's not that the whole data is in just one bucket, which is completely valuable, usable, feasible. No, that would be just certain part, and it could be figured out through the different algos. The details stays the same, and I have read a few of other white papers where the data mesh has been tried to be established, and they're just trying to work around it. So what they say is finding the right data. However, it is emphasizing to give the quality, but at the same time, it is adding a lot more cost to them. That's what they say. I mean, different papers and the people who are actually working on it, they're saying is for this data as a product and trying to follow this architecture, it is costly. It is expensive for them. So they say, I mean, not in this book. This book is typically emphasizing on the architectural part and the aspects around it. The people who are using it, they say, when we are trying to put it into the implementational area, so the core data, when we need it, it is it comes out at a very later stages, and it's a very small set. It's not a big set. That's what they say. I mean, when we say data as a product, it's a very small portion. And however, this picture is also predicting the same, that the subset, and it says the smaller part. And here, she's just trying to say that a product, it adheres to a set of rules and exhibits a set of traits and make it fit right in the intersection of Cargan's usability, feasibility, valuable, Venn diagram, which is, again, what we are talking about, the same thing here. And when we say, just saying that this principle introduce new roles to domains, such as domain data product owner and data product developer, and who have responsibilities for creating, serving, and visualizing data products. So when I went in more detail and figured out what exactly it is implying on, so it says it brings down to a team. So developers are typically, trying to produce data which falls in this area. So everything is coming, streamlining down towards the small team. And one would come as a data owner, which is kind of product owner, not exactly the data owner, because here the data itself is product. And the developers are trying to produce the data product. So it's like 3 different people. So that's how the details are coming up here. And then she says further, it says that a mesh is not merely data, it is a data product. This is what we have already seen in past too, that it has been divided in different domains, and every domain has got very influential set of data which is useful for certain area, and that is exactly not mesh, that is data as product, and it is ready to use. So one can easily just consume out as per their needs. Then it's not that they are still filtering it. So here she's trying to emphasize on it. And then she says, applying product thinking to data. So here is nothing much. That's what I have seen is she's taking the example of media player. That's in the beginning, she's taking as an example to work around. But this picture is giving us the same idea how the data is available here, the media player domain. These are the small sets. So play sessions, play events. This is actually the data. This is the products. So when she says data as products, so this is what it is, and it is ready to consume out here, right? And we have then, she's just trying to tell us all 3 different areas, as in data product developer, data product owner, app developer. So who all are responsible parties when we are taking the media player as an example. So it says that media player team, it is data user, which is very obvious, who are going to use the files through a session. And here the support team, which is again a data user, just viewing the event logs and then consuming out details and analyzing the user details and the choices, everything which is coming from the play events.
So I just want to add something here. So what I think is really important is the, like for the event log, the circle plus the little computational thing, because it's the idea of microservices. So you have some data set and then you have some compute. And there are certain cloud vendors that have created services that are more aligned to this, that have been in market for a long time. And the one I'm most familiar with is on the Google Cloud, BigQuery. So BigQuery takes data that's stored in buckets, and then you have to specify a schema or a structure. It's a text data. And then you write SQL queries against it, and and you are charged by the amount of data scanned. So it's SaaS. There's no VMs, there's no containers, you basically get charged by the query. Now, subsequently, both Microsoft and Amazon have services like this, but Google has had this since actually 2011. And when it was first announced, people just didn't believe it. Like you go to a SQL query window and you type a SQL query, and you basically get charged $5 a terabyte, because I used to demonstrate it. This was
Mhm.
2011. Think how long ago this was. No clustering, no. So they were pretty ahead of their time. But that's an example, and it's interesting because it's one of the most highly adopted services on the Google Cloud, which kind of speaks positively to data mesh, because you have this idea of a BigQuery data set, which is basically a special kind of bucket that has a schema file and then underlying text files. And then you have the piece of compute that's serverless,
Mhm.
that's just charged. So it's aligned. It's a microservice, if you will. Now, where it's not as mature is if you don't use SQL. What to me is so interesting, because when I was working in financial and advertising, those people knew SQL. So 100% of my customers use BigQuery. 100%. Every person used it because it just worked really, really well. But the compute has to be as relevant as the data. So now I'm in genomics, and genomic researchers do not know SQL. They know Python, they know R. And so what is an interesting trend around this, because I've been really thinking about, gosh, I wish my genomic researchers could just use BigQuery. But they have so many other things to think about that they don't, that the type of compute is, they don't want to learn it, right? Well, the new hot thing, which could impact this, is generative AI. Because generative AI is now making it so that you can code in English, because it's generating the query language.
Mhm.
So I think that that's an interesting technical advance that could be supportive of data mesh. Because another example of this, let's say you take the top one, would be perhaps you want to use a library like Spark, which I've had.
Mhm.
And it's non-trivial to program Spark, right? And that has been preventative for a lot of my genomic colleagues and researchers to hit the scale that they need to hit. You know, they want to use R or Python. And those things, although there is Spark R and Spark and PySpark, they don't know how to use Spark, just like they don't know how to use SQL. So the computational method for the data is not known to the user. And so the kind of the meta thing is, I just wonder if Gen AI will open up more of these computational methods. I hope so, because that would be exciting.
So this generative AI wouldn't help genomics to generate the sequels to run and make the work easier?
Possibly. I mean, I don't know about you guys, but personally, I don't use Google anymore when I'm coding. I use ChatGPT or Bard.
Yeah,
Because,
these days, yes. Yes.
right? So all of us technical people have made the switch already. It's the most highly adopted technology. So the question will be, will domain-specific experts, genomics, finance, advertising, hello, will they make, and children, will they make the switch? And they probably will, right? That's my hope anyway. So anyway, my sort of long-winded point here is, I am more hopeful about this idea of putting the appropriate compute with data, because it's been challenging, because the end users did not know the various languages. And that's been a blocker in my area to implement something like this. So you know, I'm going to be trying to work with, very practically, Bard or ChatGPT to generate appropriate SQL for BigQuery. That's going to be like a use case. Hi, Matt. Thanks for joining.
Hey, Matt.
Oh, sorry for being late.
No problem. No problem. So we were just talking about the impact of generative AI on different computational pieces. And I was using the example of a lot of genomics people don't know SQL, and so they couldn't really use BigQuery. And maybe coding in English will allow them to have more computational choices, which could help us with the different types of compute for data mesh. So anyway, so I was kind of a little bit on a tangent, but I've been thinking a lot about it. So do you have more to share, Varsha, about this chapter?
I guess more, and here one thing which I really found things which is more more towards what we actually want to see. So this picture gives me a complete idea what we are trying to get out of this architecture. So our goal is this. Here, what I think this blue circle, what I tried to line is this. Here, they are just trying to put lots of, this is what different tools will do. And here is typically coming under the validation of data. That's what I see. They say, the baseline, actually, this is saying the baseline usability attributes of a data product. What data which is ready as a product, what it should have. So these features should be there. So I think if I just put everything here, and I would just name it as a validated data, it would come more better than, that's what we were just discussing in the last 2-3 sessions, that using these fancy words, it is not giving me anything additional to do. It is not giving me any technical thing to add up here. Everything is emphasizing towards the validation. So here, of course, secure. That's what we are looking for. Valuable on its own, which is already there. We are not putting any query here to pull out much. We are assuming that it's already there. That's what they say. Interoperability, it should be. Natively accessible. So again, that's what we were just discussing about, not depending upon any much languages, and that's what I understood, that if I want to fetch it, I can easily do that without depending upon any specific certain language. It is available there. And then when they talk about it here, like discoverable, addressable, understandable, truthful, or trustworthiness, everything comes under the validated part. That's what I think is. Now, what's your views are? What do you think about it?
Well, I'm going to jump in again because, again, I've been in this business for a long time. And to me, it was a radical shift when you go from data warehousing to data lakes.
Yeah.
Data warehousing, you don't have the discoverability sort of issue to the extent because you write SQL queries. It's kind of a known paradigm. But when you go to lakes, like I mentioned it earlier today, but it was shocking to see what a mess lakes are, because it literally is they call it data swamp, and the vendors have really oversold because, the expandability of the cloud, it'll be so much cheaper. It's what you said earlier, Varsha, the actual papers are saying it's not that much cheaper because of the low level of maturity. You don't magically, just think about it. If you have millions of files in buckets, how do you find things?
Sure.
Right?
And the vendors had this huge, and continue to have this huge, almost counter incentive, because they're going to charge you based on consumption.
Mm-hmm.
And so they're sitting there, they don't want you to put cleaned, efficient data in the data lake. They
Right.
want you dumping terabytes,
Right.
petabytes of data that you are never going to touch, that is immediately going to drop to a cold, then an archived here, and they're just going to bill you for the rest of time.
Right. Hey, Varsha, do you want to stop presenting and then we can see each other better? Yeah, so I call it the EC2 problem, right? So, it was very well known that the Amazon console was hard to find your EC2 instances. The big joke was that Amazon didn't fix that until relatively recently because, people would turn on EC2 instances and never find them. And that's how Amazon was making all its money. So that's from a compute point. And it's, as Jason was just saying, the vendors are kind of incented from a data point. Oh, it's easy. Just make it buckets super easy. I was guilty. I was that consultant going, yeah, it's easy. Just put all your data. And then, oh, shoot, what do we do now? How do we make it usable? So this idea of metadata tagging is really interesting. I'm working with one customer right now, and they're coming from a colo, and it's a huge like SAN environment. And so it's folder structure, right? So all the metadata is encoded in the old-fashioned way, in folder hierarchies, right? A folder and a folder and a folder and a folder. And so what we're working on right now, it's new kinds of problems when you do files, right? If it's database, you just database and then you add, lineage or whatever, right? Yeah. Right? Jason's point, metadata, another great space for generative AI. Yeah, but I mean, just from a plumber point of view, as we're pulling the data off the SAN and putting it into buckets, we're writing scripts to retrieve those folder hierarchies and write that out as labels.
Mm-hmm.
I mean, a lot of the stuff is not very elegant. And to Jason's point, it would be great if we didn't have to do that, if generative AI just did it, So there's a whole bunch of tasks that AI is going to be able to help around identification. But really, in my opinion, and I see Jason nodding, just was a complete different ballgame to go from data warehouse to data lake.
It was, I'd like to think that I'm pretty up on data warehouse technologies and everything. And when I made that shift, it was a road bump. It was bigger than the move from OLTP to OLAP, honestly.
Yep, totally.
It's not just, and this comes back to the data product concept. It's not just how you approach the data, but it's who your users are. Once you're starting to use a data lake, data warehouses access, build, everything is so complex about them that you can count on the people who even know they exist not needing to worry about discovery, not needing to worry about, because basically to know they exist and then to use them, you're already talking graduate level work or graduate level understanding of the concepts. Data lakes are a different story, and where the business and the clients are going with it is a totally different story too. They want democratic data. They don't just want their people to access it. They want to make it available to the whole world. They just want to know what they're making available to the whole world. And that's a totally different paradigm, because that's not walking around in your Intel bunny suit and very carefully extracting the one piece of information you're interested in. And to come back to my experience in education, that's every teacher being able to analyze data and find the piece of information that interests them. And then being able to take that and use that maybe in ways that the official organization doesn't expect and isn't ready for. And go ahead.
Sorry. Well, I got the speed version of that during COVID, because literally, again, I just cannot tell you how mind-blowing it was when we had the presentation in April of 2020 with 16 researchers going around the globe, because it was that time for the world, starting with the genomic references from China and ending with the doctor who got the tissue from the patient who just died, and trying to talk to each other. I get sort of goosebumps when I talk about it, because there's nothing that drives change like a crisis. And in genomics, what it caused like that, because before the data was siloed and people had to write and have request access and la 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 la, and suddenly we were in a pandemic and we had to figure it out. And what has happened as a result of that is researchers, it's opened Pandora's box, have discovered what is possible if they do collaborations. And so now they're putting these demands on the IT departments, like you said, for the teacher case, but I'm in it with the genomics. I literally have a customer right now. They've got a multi-million-dollar grant. They're supposed to work with 15 organizations, and they don't even have their own data available to their own people. And the money is there, and they have to figure it out. So it's exciting. And like I said, that's why I'm interested in Gen AI, because I need to teach a lot of people a lot of things really fast. Because that idea of the data with the compute is to me, that's the fundamental shift with data as product. Because data quality and all that stuff, like you said, Varsha, that's been there in data warehousing for a long time.
Yeah.
But it's the matching the compute like a microservice. And again, I've seen more of that probably than a lot of you guys because of the variety of data. I mean, one day I'm working with 30 gigabyte images. The next day I'm working with, you know, genomic references that are in the terabytes, right? And the computational complexity, everything is a custom neural network. It's really, it's really out there on the cutting edge. I mean, I think back to when I had kind of small and medium businesses and they were doing e-commerce or something. And I was like, wow, this is just a different plane. But I do think that genomics is going to inform so much of the rest of the data world because the collection that we're doing, you know, they're saying with IPv6, there'll be multiple addresses for every person on Earth, right? Whether we like it or not, it is basically leading the way. So we're going to have this volume of data in other domains. Genomics is sort of leading. But yeah, this idea of aligning the compute with the data to me is like the mind-blowing thing. And again, I'm in it right now. I'm working on one case. It's spatial multiomics. And so you've got image data, you've got genomic data, you've got 16 different microscopes for different kinds of cancer tumors. So you have different kinds of compute for different kinds of image data. And trying to figure that out is really a new pattern. You know what I mean? It's not throw it all in the data lake and let BigQuery do it. You can't do that.
That's what she says about the friction here. So what the challenge, what you see here is actually with the compute and then data is the friction. You know, the moment we have that connectivity, the way if we are just aligning it some way, obviously it will happen gradually because things are happening, changing every day, and everybody's just working. So I'm sure it will happen, but the moment it is eased out, we have a lot more access to the usable data. That's what she's, I guess, emphasizing there. So our challenge here is, since beginning, what I'm saying here is, for us is more of the technological challenges, not the conceptual. Concept is there. I mean, we know if something is real big and it's so hard to drag or to drive in, we make the smaller pieces to make it more easily, you know, organized. That's what we do. But then how we are trying to connect in the same shape, even if it is cut and small. So this is what is happening right now. When I see everything what we are talking about right now and the book, it is pretty much similar. The only thing is how smoothly are we connecting the compute and the data and making it available for the actual target audience. I read a course in the past week. It was DeFi, the decentralization of finance. The way it is being changed, it's my perception. They didn't mention it anywhere, but I saw that how nicely they have segregated and easily, mutually interacting, and still, intact in that their own domain. This is what probably the new scenario is looking for. It's big, variety of data. Why not, categorize, make it small, and we have to only keep it in a way that it is accessible only to the authenticated areas. That's what probably the only solution what comes up right now.
Well, and again, what I'm seeing that look like, to put a pragmatic spin on it, in GCP is buckets and BigQuery data sets. And the difference is a BigQuery data set is, it actually is a kind of a bucket, but it's got a schema to it. And these are combined as zones, as I showed you in the demo a couple weeks ago. And so you can put any collections of those together. There are other things you can put in there like streams and stuff like that. And that seems to be similar in Amazon from the demo Norman showed with S3 buckets. And Redshift, Redshift data warehouses. I don't know, Jason, if you've worked with Azure at all. I'm sure buckets are in there, but is there, what's the other piece?
It's all lumped together under a concept called Synapse. Then there's also Databricks, which is kind of an overarching cross-platform thing that does all of this plus a little bit more. But Synapse is an interesting, what Microsoft is trying to do is really hardcore combine that compute into the data exactly in the way that you're talking about. So you have different varieties of Synapse. You have Synapse serverless, which behaves exactly like GCP. But then you also have what are called Synapse dedicated pools. And what those are imagine you wanted to define and make available data warehouse structures predefined. So not just the schema, but the capability for things like views and they're really chasing Databricks on this. But I think that they're getting there, and in some ways are moving ahead conceptually with this idea of being able to transition through and make things available in a way that fits with an organization's business model. I don't think that they're going to be going after the academic or the genomics type use case. I think finance, so kind of the higher end of big data, when you're looking at it from an organizational scope, is probably more what they're looking at. So like you want to see finance data, you want billions of transactions a second to be able to be processed, but you also want to integrate that with a half dozen other dimensions as well to use data warehouse concepts. And I think that that's where they're going with it. I don't, like I said, serverless is powerful and it can get there, but it's going to cost you a lot to get the same scale that BigQuery will.
Yeah, it's interesting because Google came out serverless first with BigQuery, and then the other guys kind of added it on. And serverless was adopted first, as you know, by startups, right? Because it wasn't enterprise grade, it wasn't enterprise security, and so that's the sort of negative to it. And Google has been adding on the security as we go, whereas Azure and AWS have been adding on serverless for the agility, right?
Right.
But the thing that you mentioned in there, I think is important to also know, there are other types of compute. I actually have a lot of experience with Databricks. Databricks is the productized version of Apache Spark. It's the Spark team. And Spark, of course, is Hadoop, but it's in memory, which is the difference. In Hadoop is on disk, which is the technology that came out of Google to index the entire web. So it's the massively scalable data processing with custom serialization. So Databricks is an interesting player because they the Spark was formed by genomics, always genomics, right? Because the hard problems, right? The guy who started Spark, he said, I need like Hadoop, but I need it faster. I need it in memory, right? When he was at Berkeley. And then in a typical Silicon Valley style, they got just a lot of venture money and turned it into a company. And they went out first on Amazon, and then they added Azure and now GCP. So Databricks is a commercial company that offers Spark as a service and tools. And so they've been phenomenally successful providing value to data lakes because they can serialize what's in a data lake. That's one of the reasons they are so successful. So it's interesting is you have Databricks at the commercial level, and then you have Apache Spark. And some of the vendors, Google in particular, have said, because they're such engineers, right? Well, they built Spark, but we're going to Googleize it and have the Google version of Spark, which they call DataProc. One of the things that I don't know who came out first, but I'm sure excited about it, is Databricks was first with Spark serverless, which is kind of like a competitor to BigQuery. So you write in Spark, so Python or Scala or whatever, rather than SQL, although there is Spark SQL, just to make things confusing. But now the cloud vendors have serverless Spark. So Google's is in preview, and I've been trying it out. It's super cool. So again, matching the compute to the user. You're in a Jupyter notebook. You've got a runtime in a Jupyter notebook, like Python or R or whatever. You're building your model. You're looking at your data. You now want to do your model training. You have your genomics. You need a poof to do your model training, right? You need a scale session. So that's what you can now get. I call it the magic button, serverless Spark. And you can change the runtime from a local, Python or whatever, for a cell in a notebook. So for the model training cell, you can go, for this cell, I'm going to want to go and do that serverless Spark session. I know. Now that's matching the compute to the data, because the researcher's in their notebook and they want the superpower button, right? And there's other, I think all the vendors have it now too. I don't know Microsoft, but I think so.
It's inside Synapse.
Yeah. So they all got this, but most customers don't know about this yet. Because again, this concept of matching the compute to the data for analytics, to me, is one of the fundamental ideas of the book, but it's a fundamental idea of this chapter. And it's as technical implementers and educators, it's something that, I'm working on with my clients, because they just don't, this is a new idea. This is one of the big new ideas, I think. And I'm obviously excited by it, because I like the superpower button. Oh, it's so cool. You just go serverless.
It's the ability to, I don't know if you've had a chance to play with Hyperscale SQL at all, the new stuff out of Postgres. If you've got pure structured data, it is a dream. Like, I remember sitting in a meeting with Intel going, look, there's just got to be a way to split this compute up. I can hit the storage. Right. Just give me the ability to split it up. And they're like, oh, well, you have to use Hadoop. And I'm like, I don't want to use Hadoop. Nobody understands Hadoop. And what they've done with Hyperscale is exactly that. They built it on, I think it's built on Spark, actually, and just uses a Postgres translation layer to give you actual SQL rather than Spark SQL. But it's amazing. And
so there's two aspects of this custom compute for data. One is Spark type libraries or BigQuery type libraries, right? The power button. The other one is hardware. So the other thing that I've done a lot of work with in genomics is certain types of, again, model building will benefit from taking aspects of the model building and putting it on an FPGA chip, a GPU, even as in Google, you have TPUs. And then I've done perf testing with different kinds of GPUs. So this idea of matching the compute to the data for analytics is kind of the new hotness, before it was like tune your data warehouse, and now it's tune your little piece of whatever that you're using for the time. And that's interesting to me, because you do it for front-end microservices, and yes, there'll be some, big websites or whatever, you have to tune it. But I think it's like more the use case for data analytics, because you have aggregate data, no matter whatever your domain, it's going to be a lot of data, right? And so it's kind of the new query tuning in a way. We're all old enough, right? Like if I made a lot of money doing indexing and partitioning and rewriting SQL queries, it's kind of that, but it's which engine, which language, and which hardware. So
Intel has a whole division, actually, that of architects that will actually work with you on that. It's amazing. Have you had a chance to use the new, well, it's not so new, but they're just starting to publicize it, the CUDA on Databricks?
Yes.
Oh my God. It's crazy, isn't it?
Well, and just to be this, since we're getting to the top of the hour and we're really nerding out here, or I am anyway. Sorry, the rest of you just are. I'm inflicting myself. But Matt, since he was in my other book club, of course, the ultimate power button would be a QPU, which the cloud vendors all have. And again, not to be a broken record, but there are papers published in cancer image analysis on, they call QCNNs, quantum convolutional neural networks, where faster and more accurate. So again, this idea of understanding the appropriate hardware, and of course, there's always going to be cost benefit. You get what you pay for, right? Like not everybody is going to be able to afford TPUs or QPUs or whatever, right? But it's a really different way of implementing what we all knew as query tuning in data warehouses.
One interesting thing I remember from that book study too was we found that quantum computing has very niche areas that it could be extremely good at. But for your general algorithms, it was worthless. Yeah. So that really brought home, I had to go back in my old school days. Yeah, when we first had GPUs, it's like, okay, your CPU and your coprocessor and everything, you're going to handle your day-to-day, but you're going to take this graphics processing logic and throw it at the GPU, let it do its work and get it back or whatever. And the idea that you would have an algorithm like this whole data pipeline. Okay, this piece or this cell is a QPU. This cell is something else.
That's right.
And you're going to stitch it all together. And I think that's going to be a differentiator too, because you're going to have some workloads that, you know, Lynn, you're going to have a whole nother career making lots of money saying, let me tease out the QPU and TPU portions. And you're going to take your entire model that used to take hours and hours or longer and trim it down to, 30 minutes or 10 minutes or whatever. But, and then you have your different cost factors for that too, right? There's a whole nother cloud. We're going to slice your cost.
Right.
You want it done in 5 minutes, but it's using a few QPUs, or do you want it to run 24 hours because you're on traditional or longer? Who knows? But it is fascinating.
Yes, it really is. So we are already at the top of the hour. Thanks to Varsha for leading. I really appreciate it. Next week, we're going to be on chapter 4.